Imagine a backhoe just completely severs the main power line to your server building.
Oh, man. Total nightmare.
Right, total blackout. And let's say 100 of your company's users were right in the middle of running these massive, heavy financial updates.
Just worst case scenario.
Exactly. If screens go dark, is all that in-flight data permanently gone?
I mean, if you're sitting across from a hiring manager for an Oracle database administrator role, your answer to that scenario, it absolutely cannot be a guess.
It has to be rock solid.
It definitely does. And, that scenario perfectly illustrates why rote memorization just completely fails in these interviews.
Yeah, people just drill in flashcards.
Right, trying to force all these fragmented facts into short-term memory. But database administration isn't about reciting trivia, It's really about understanding an entire ecosystem.
Which is actually the core mission of our deep dive today. You brought us this highly authoritative, really dense set of 81 common Oracle DBA interview questions and answers.
Yeah, it's a beast of a document.
It is. And instead of just reading them like a textbook, we are translating this source material into an audio masterclass specifically designed for you, the listener.
Absolutely.
Whether you're walking the dog or commuting to work, the goal here is for you to effortlessly refresh, memorize, and just gain absolute clarity on these concepts.
Because we're going to map out the hidden matrix of how an Oracle database actually thinks.
Right.
Because when you understand the underlying mechanisms like the why and the how, you stop worrying about what specific question the interviewer might throw at you.
You just follow the logic.
Exactly. You follow the architectural logic, and the correct answer just naturally reveals itself.
Well, let's test that theory. Let's start at the absolute foundation. An interviewer is almost always going to verify that you understand the fundamental split in Oracle's architecture.
The big one. Instance versus database.
Right, the difference between an instance and a database. Now, anyone taking this interview knows that RAM is volatile and hard disks are permanent, but how does Oracle specifically divide its labor across that hardware?
So in Oracle, the instance and the database are treated as two distinct entities that just happen to interface with one another.
Okay.
The instance is entirely volatile. It lives entirely in your server's RAM and consists of background processes and memory structures.
Got it. And the database?
The database, strictly speaking, is the collection of physical data files, control files, and redo logs that actually reside permanently on your storage disks.
So the instance is like the engine running in memory, and the database is the actual fuel sitting in the physical tank.
That's a great way to put it, yeah.
So if we are tracking the life cycle of a user, they don't interact with the data files directly, right? They connect to the instance.
Yes. And according to the material, that initial connection always starts at the listener.
The listener, okay.
Yeah, the listener acts as the gatekeeper. It literally just listens on a specific network port for incoming connection requests.
But it doesn't process the queries itself.
No, that's a crucial architectural detail. The listener doesn't actually process the user's queries at all. Its only job is to hand that incoming connection off to an Oracle background process called PMON.
Process monitor.
Exactly.
Okay, but before PMON actually lets you in to do any actual work, it has to verify your credentials, right?
It does.
The text notes that PMON checks your identity against the base tables. I want to unpack the mechanism here a bit. What makes these base tables so special that PMON relies on them for ultimate security?
Well, base tables are basically the foundational dictionary of the entire database.
Okay.
They are heavily encrypted binary tables, and they reside in the system table space. They store the core data about the database itself, which includes all the user credentials and privileges.
It's the master list.
Right. And the critical mechanism to understand here is that no human user, not even a senior DBA, can directly modify these base tables.
Wait, really? Not even the top admin?
Nope. Only Oracle's internal background processes are allowed to alter them. If a human somehow bypasses the system to edit those files directly, the entire database just becomes completely corrupted.
Wow. Okay, so PMON checks the highly secure base tables, verifies you, and spins up a dedicated server process for your session.
You're officially through the front door.
You're in.
Yeah.
And this actually brings up a classic interview trick question from the sources.
The crash scenario.
Yeah. The hiring manager asks, you have 100 users actively connected and running queries. Suddenly, the listener process crashes. What happens to those 100 users?
See, if you rely on memorization, you might panic and say the users all get disconnected.
Which feels intuitive. The thing listening is gone, so the connection drops.
Right. But if you follow the logic we just mapped out, the answer is obvious. The listener only handles the initial handoff. Once PMO has created the server processes for those existing 100 users, the listener's job for them is already done.
It's totally out of the loop.
It's
It's like a receptionist at a secure building. The receptionist checks my ID, gives me a badge, and escorts me to a private meeting room.
Right.
If that receptionist suddenly falls ill and has to go home, it doesn't stop the meeting I'm already sitting in.
That is the exact mechanism.
Yeah.
The existing sessions continue completely uninterrupted.
But the front door is locked.
Exactly. Only new connection requests will fail because there's nobody to open the door. Explaining that handoff mechanism to the interviewer proves you understand the session lifecycle, rather than just reciting a memorized outcome.
Yeah, it shows you actually know how the gears turn. Okay, so the user is safely inside the instance.
We're in the building.
We're in the building. The next phase an interviewer will probe is memory allocation. Where does the actual heavy lifting happen? The architecture divides memory into two main camps, right? The SGA, which is the shared global area, and the PGA, the private global area.
Yeah, and the naming convention pretty much gives away the function.
Shared versus private.
Exactly. The SGA is this massive shared memory pool. Every single user connected to the instance reads and writes data through the SGA. It's completely communal.
Like the open plan office.
Yes. The PGA, however, is created exclusively for a single user session. Remember when PMON spun up that server process for you?
Yeah.
Well, it allocated a chunk of private RAM right then just for your session's specific tasks.
Okay, tasks like an in-memory sort. The source material really emphasizes this.
It does. It's a key concept.
So if I run a query that requires filtering or organizing a bunch of data, Oracle attempts to do all that sorting privately inside my PGA.
It tries to, yeah. It wants to keep it private and fast.
But what dictates the physical limit of that private sorting space? Because there is a very specific trap interviewers use regarding the temp table space.
Oh, the temp table space trap. It's a classic. Usually sounds something like this. Candidate. A user is running a massive query. The temp table space fills up completely. You, as the DBA, add 20 gigabytes of space to the temp table space. An hour later, it's 100% full again. What is your next move?
I mean, my instinct, if I don't understand the mechanism, is just keep feeding the beast. Just throw another 50 gigabytes of disk space at it and pray the query finishes.
Which is exactly what a junior DBA would say.
Right.
To give the senior answer, you really need to explain why data ends up in the temp table space to begin with.
Okay, lay it out for us.
When a user runs a sort operation, Oracle tries to do it at lightning speed inside their private RAM, the PGA. But if the dataset is too massive to fit in that allocated PGA memory, it spills over onto the physical hard disk.
And it specifically spills into the temp table space.
Yes, exactly.
So the temp table space is basically Oracle's overflow parking lot.
That's a perfect analogy.
If the overflow parking lot keeps filling up, the solution isn't to just keep paving over more of the neighborhood. The solution is to figure out why so many cars are arriving all at once.
Precisely. The senior DBA response is to stop adding space immediately and start tuning the actual query.
Look at the code.
Right. You investigate why the application is asking the database to sort millions of rows inefficiently. Perhaps they're missing a critical index, which is forcing a full table scan.
Ah, so you diagnose the root cause. You don't just endlessly accommodate bad code.
Exactly. You have to fix the leak, not just buy a bigger bucket.
That makes perfect sense. And speaking of memory limits, the instance itself resides entirely in RAM, meaning space overall is fundamentally constrained.
It's always a battle for real estate.
The text notes Oracle manages this constant battle using the LRU algorithm, least recently used.
Right. The LRU algorithm is basically the heartbeat of Oracle's memory management.
How does it work?
Well, because the communal SGA can't possibly hold the entire database at once, it has to constantly cycle data in and out of RAM. If a piece of data is queried heavily, it stays right at the top of the LRU list. It's safe. But if a data block hasn't been touched in a while, it gradually moves to the bottom of the list until it gets evicted to make room for fresh data.
Just constantly churning.
Exactly.
Which brings us to the most vital job of any database, really. Survival.
Yes, data integrity.
Keeping data in memory is great for speed, but if the server loses power, like our backhoe scenario, everything in RAM is just completely wiped.
Vaporized.
So how does Oracle safely move changes from that volatile LRU list down to the permanent physical disks? Let's trace an update statement.
Let's do it.
Say a user decides to change a salary value from $50,000 to $60,000.
Okay, so before Oracle even attempts to change the actual data, it prepares for the possibility that the user might issue a rollback command and cancel the transaction.
It anticipates them changing their mind.
All right, so it takes the old value, the $50,000, and writes it to an undo block. Then it places the new value, the $60,000, into a memory block within the SGA. At this exact moment, that memory block is classified as a dirty block.
Dirty, meaning it has been modified in the volatile RAM, but that new value has not yet been permanently saved down to the hard disk.
Correct. And simultaneously, Oracle is generating what are called redo entries.
Redo.
Think of redo entries as incredibly detailed sequential diary entries that log every single action taking place. Like user X is changing row Y from $50,000 to $60,000.
It's just a running log.
Yes. And this leads us to the absolute golden rule of Oracle architecture, which involves two core background processes.
The log writer and the database writer?
LGWR and DBWR, yes.
So according to the source, the golden rule states that the log writer must write the redo entries to the physical disk before the database writer is allowed to write the actual dirty blocks to the data files.
That is the rule.
I actually want to push back on this design choice for a second.
Okay, sure.
Why introduce this two-step bottleneck? Wouldn't it be safer and just more efficient to have the database write the modified $60,000 directly to the physical disk as fast as possible?
I get why you'd think that. It seems like a bottleneck until you analyze the mechanical physics of hard drives.
Okay, physics.
Writing actual data blocks to physical data files is a heavy random access operation. The database writer has to scatter data all over the disks. It is mechanically very slow.
Because it's hunting for the right spots.
Exactly. The log writer, however, is just writing a sequential diary entry to the redo logs. It writes in one continuous stream, which is incredibly fast.
So it's prioritizing a fast sequential diary entry over the slow, heavy lifting of filing the actual data blocks.
Yes, because in database architecture, transaction recording is always prioritized over transaction execution.
That is fascinating.
Let's go back to your backhoe scenario. The user commits the salary change. The log writer instantly streams that redo diary entry to the physical disk. A millisecond later, before the slow database writer can actually save the dirty block to the data file, the backhoe cuts the power. Total blackout.
Boom.
Yeah.
The RAM is wiped. The dirty block holding the $60,000 is completely vaporized.
It is.
Gone.
But when you restore power and reboot the server, Oracle immediately checks the permanent redo logs.
Oh, it reads the diary.
It reads that sequential diary entry, sees the committed $60,000 change, and mathematically reconstructs the lost dirty block in memory. It replays the entire transaction.
Wow.
Without the golden rule of log writer first, that data would be permanently lost.
That completely flips how you normally think about saving work.
It really does.
Now, to keep this gap between the fast notes and the slow filing from growing too massive, the source mentions checkpoints.
Right. Checkpoints are critical.
Checkpoints are basically database events that force the database writer to hurry up, catch up, and sync the memory blocks with the physical disks, right?
Yeah, and interviewers will test if you know how to control that catch-up process. It's managed by a specific parameter called fast start MTT target.
Which defaults to just 3 seconds, the text says.
Correct. And it represents the tension between performance and recovery time.
How so?
Well, if you checkpoint constantly, your database performance suffers from all those constant disk writes.
It's bogged down.
But if you checkpoint rarely, a system crash means Oracle has to read through mountains of redo logs to reconstruct the data, which massively delays your startup time.
So it's a balancing act.
Exactly.
Okay, so the log writer saves us during a power outage. But what if it's not just a power outage? What if the physical hard disk itself is destroyed?
The real disasters.
Right. Interviewers love testing disaster recovery scenarios, and everything in a disaster revolves around one thing: the control file.
The master map.
Okay.
The control file is the master map of the entire Oracle ecosystem. It dictates the physical location, the size, and the status of every single data file and redo log in the database.
So if you lose the control file,
Oracle has absolutely no idea where its own data is stored. It's blind.
because it's the master map, the text explicitly states you must multiplexes, meaning you have to have a minimum of 2 copies.
At least 2, yes.
But here's the trick scenario an interviewer will pitch you.
Let's hear it.
We run a highly secure environment. We have 4 multiplexed copies of the control file, and they are all safely stored under the U01 mount point. does this meet disaster recovery standards?
Right, and the trap there is the physical location.
The UO1 directory.
Exactly. If you have 4 copies of your master map, but they all reside on the UO1 directory, you are relying on a single physical hard drive.
So if the disk supporting UO1 suffers a mechanical failure,
You lose all 4 multiplex copies simultaneously. Poof!
don't put all your maps on the same hard drive.
They absolutely must reside on distinct, separate physical disks.
So how does Oracle actually utilize this map when it's starting up? The material distinguishes between the mount stage and the open stage. What is the actual mechanical difference there?
Good question. When you boot a database into the mount stage, Oracle basically locates and reads the control file. It loads the map into memory.
Okay.
However, in the mount stage, Oracle does not physically verify the territory. It doesn't check if the data files actually exist where the map says they do.
It just blindly trusts the paperwork.
Completely. Until you issue the command to transition to the open stage. That is when Oracle performs a strict reality check.
The open stage is the reality check.
Yes. It validates the control file's contents against every physical data file and redo log. And the primary mechanism it uses to verify everything is the SCN.
The system change number. I definitely want to break down the SCN because the text mentions it constantly.
It's vital.
How does the SCN actually function during this validation?
Think of the SCN as a unified digital ticking clock for the entire database. Every single time a transaction commits, the clock ticks forward.
Tick, tick, tick.
Right. And Oracle stamps this exact SCN timestamp into the header of the control file and into the headers of all the physical data files. So during the transition to the open stage, Oracle compares the timestamps.
Okay, so if the control file's SCN clock says 12.00, but one of the physical data files has a header stamped at 11.55.
Oracle immediately spots the discrepancy. It realizes the timelines are out of sync.
Because maybe someone restored an old backup?
Exactly. It means a data file is old. And Oracle will outright refuse to open the database until you initiate media recovery to roll that older data file forward so its clock matches the rest of the system.
Wow, that is a phenomenal safeguard.
It really is.
There's one more disaster scenario in the text that ties directly into our earlier conversation about redo logs. What happens if your archive log destination gets completely full? The text says the database will, quote, hang.
It freezes completely, just stops dead.
Why?
To understand why it holds its breath like that, you have to look at the life cycle of those redo log diary entries. Redo logs are cyclic.
Right, they loop.
Oracle writes to log group 1, fills it up, moves to log group 2, fills it up, and eventually circles back to overwrite log group 1 again.
But wait, if it overwrites the old diary entries, you lose your historical record for disaster recovery.
Which is exactly why the archive process exists. Before Oracle is allowed to overwrite log group 1, it absolutely must make a permanent backup copy of it, an archive log.
And it stores that copy in a designated destination folder.
Yes. So if that destination folder runs out of disk space, Oracle cannot save the archive copy.
Oh.
Therefore, it refuses to overwrite the original redo log. It just halts all database activity to protect your historical data integrity until a DBA comes in and clears space in that folder.
That is wild. It just goes on strike to protect the data.
Essentially, yes.
Well, that transitions us perfectly from these catastrophic disasters into the unintended consequences of a DBA's daily choices.
The day-to-day grind.
Yeah, a massive part of the interview is proving you won't accidentally cause these system hangs yourself through just poor management. Let's look at parameter management. The database uses either a file or a file.
Right, and they both serve the exact same purpose, telling the instance how to configure itself and allocate memory upon startup. But mechanically, they operate entirely differently.
How so?
Well, a file is a static, human-readable text file.
Let's visualize the difference. A file is like a printed blueprint of a factory. If you decide you need to widen a hallway to allocate more space, you have to draft a whole new blueprint, shut the entire factory down, and restart operations using the new design.
That's a really solid analogy because a file requires a total database reboot for any parameter changes to actually take effect.
But this file is different.
Very different. And file is a binary file. You cannot read it or edit it with a standard text editor.
So this file is more like a live digital dashboard. You can tweak the settings, and the factory physically adjusts its internal walls while production is still running.
Yes, and you control that live adjustment using the scope parameter.
Interviewers will definitely ask about the scopes.
Oh, guaranteed. They'll ask you to define the 3 scope options.
Lay them out for us.
If you set scopes fail, the database updates the file, but the change won't actually take effect until the next reboot.
Okay, delayed effect.
If you set scope memory, The change takes effect instantly in a live system, but the file isn't updated, meaning the change just vanishes after a reboot.
Temporary fix.
Right. And if you set scope both, the system adjusts immediately and writes the change to the file permanently.
Understanding those scopes is critical. I mean, it prevents you from accidentally bringing down a production server just to change a memory limit.
Exactly. You have to know what you're touching.
Here is another daily choice that leads to huge unintended consequences. User privileges.
Always a minefield.
Say an application developer asks you to create a new user account and casually says, hey, just grant the account the resource role, it makes things easier.
A junior candidate might agree, thinking, it's just a standard developer role. But a senior DBA pushes back immediately.
Why?
The resource role is a huge trap. Historically, granting that role to a user quietly grants them an unlimited quota on their default table space.
Wait, unlimited? Meaning that single user could run a bad script that endlessly inserts data until it consumes every gigabyte of physical storage on your server.
Yes. Freezing the entire system.
Wow.
You've essentially given them a blank check. As a rule, you always grant quotas explicitly. You never rely on the resource role's hidden baggage.
Let's talk about another hidden resource grain, snipped sessions.
Zombie processes.
Yeah. The text describes a scenario where a user logs in, runs a query, and then just goes on vacation while leaving their connection completely open. Oracle eventually hits an idle time limit and marks the session as snipped.
Right. And on the surface, it sounds like Oracle successfully cleaned up its own house by terminating that idle connection inside the instance.
It sounds like a success.
But the trap lies in the underlying operating system. Oracle cleaned up the memory structures in the SGA and PGA, sure. But the dedicated OS-level process that PMO originally spun up for that user, it might still be running.
So it literally becomes a zombie process.
Exactly. It's doing no actual database work, but it's still sitting there consuming CPU and RAM at the server level.
If you have hundreds of these snipped zombie sessions, your server just grinds to a halt.
To mitigate that, you really have to ensure the database parameter resource limit is set to true. And you often have to write OS-level scripts to actively hunt down and kill those orphaned processes.
Which proves to the interviewer you manage the whole server, not just the Oracle software.
Exactly. You have to think outside the database.
Let's do one final daily trap, and it's a network issue. A user complains they cannot connect to the database. You verify their tnsnames.aura configuration file is perfectly formatted. You run a TNS ping command from their machine to test the connection, and the ping completely times out. Where's the failure occurring?
The mechanism of a TNS ping is really important here. It tests the network path to the Oracle listener.
Right.
It doesn't actually attempt to log into the database itself. It just walks up to the server building and knocks on the outer door.
Okay.
The default network port for Oracle is 1521. So if the configuration is perfect, but the TNS ping fails, the issue is almost certainly a blocked port at the network firewall level.
So you stop digging through Oracle configuration files and you go call the network security team.
Exactly. You isolate the layer where the failure is actually occurring.
Man, if you're listening to this deep dive, take a moment to look at the massive amount of ground we've just covered. We started at the front door, tracing the handoff from the listener to PMON.
Yep.
We unpacked the volatile memory of the PGA versus the permanent security base tables. We explored the life-saving physics of the log writer, prioritizing redo diaries over physical data blocks.
A lot of mechanics.
We navigated the disaster recovery mechanics of SCN ticking clocks and mapped out the unintended consequences of spile parameters and zombie sessions.
We covered an incredible amount of technical architecture. But more importantly, we connected the dots,
Right.
When you sit in the interview chair, you aren't retrieving isolated data points from flashcards. You are explaining the causal logic of a fully integrated ecosystem.
And to leave you with one final thought about the mechanics of that ecosystem, the source material briefly outlines a feature called OMF, Oracle Managed Files.
OMF, a really fascinating feature.
It allows a DBA to create new table spaces and data files without having to specify a physical file name or a directory path at all.
Right.
You just issue the command, and Oracle automatically generates a unique file name and places it somewhere on the disk based on its own internal parameters. It's designed to completely eliminate the daily administrative typing burden.
It is incredibly convenient for rapid provisioning.
But
and this is the text adds a really subtle warning about the resulting naming convention.
Right. So if you're preparing for your interview, just ponder this scenario. You've utilized OMF for years to save time. One night, a catastrophic disk array failure corrupts your multiplex control files. The database crashes and completely refuses to mount.
Oh, no.
To manually reconstruct the database and perform media recovery, you need to use the operating system command line to physically locate, verify, and perhaps relocate specific critical data files.
Which you need the names for.
Exactly. But because you surrendered control to OMF, you have absolutely no idea what cryptic, auto-generated names Oracle assigned to those files, or which nested folders it buried them in.
The convenience of automation suddenly becomes an administrative nightmare during a crisis.
As a database administrator, your ultimate responsibility is recovery, not convenience.
Huh.
Is the daily time saved by abstracting file management really worth the total loss of manual control when the underlying hardware actually fails?
It's a tough trade-off.
Think about how you would justify your use of OMF to a hiring manager, because your answer will reveal exactly how you balance operational efficiency against real disaster survival. We'll leave you to explore that logic on your own. Good luck on the interview, and thanks for joining us on this deep dive.